A very good morning, student. Today we will start our lecture 9 on determination of infiltration rate of the soil. In the very first class, we defined the infiltration definition. It is the downward entry of water from the upper layer of the soil to the below layer of the soil. We call it as infiltration. So, what is the technique or instrument that is required to determine the infiltration rate? The infiltration rate refers to the water from the surface of the soil, and the infiltration rate is the soil characteristic determining the maximum rate at which water can enter the soil under specific condition. So when we know about infiltration, the rate refers to the at what pace water is entering from the top layer of the soil to the below layer. We call it as infiltration rate. It is important soil property based on the rate of water application, time required to apply, and appropriate amount of water can be decided. So the material required for determining the infiltration rate of the soil is the galvanized iron open-ended cylinder of 60 centimeter and 30 centimeter diameter. We require an iron plate, hammer, scale, bucket, jug. So this is the double ring infiltrometer. So outer ring and inner ring. We have a hammer. We require a scale to measure the amount of water infiltration in the soil. So what is this procedure? First is survey the area and select a fairly suitable level land for installing the infiltrometer. So infiltrometer should not be selected in such area where there is a waterlogging or at a high hilly area. So at a plain land where you want to measure the infiltration, place the ring in such a way that two cylinders are concentric with each other. The two cylinders are concentric with each other. This is the first cylinder and the second cylinder. This is the concentric circles with each other. This is the concentric circle. The next, remove the iron plate and place the outer ring kept at equidistance from the inner ring and hammer the ring at a depth of 20 centimeter. So you have to place this ring in a concentric fashion and hammer the ring at least at a depth of 20 centimeter inside the soil. Then next, add water in the space between the two rings and maintain the level throughout the proper determination, and then the water level in the outer ring is constant. So we call it as a buffer zone. You have to place the ring, you have to hammer it at least so it should go 20 centimeter deep inside the soil. Then what you will do, you have to irrigate the outer ring. This become a buffer zone such that there is no seepage loss of water. When you outer ring, here it is saturated and here it is saturated, and here you have metal sheet, right? So this zone is saturated with the water, so this becomes a buffer zone, and you want to measure the infiltration rate only from this particular zone, from the inner ring. The next, add water in the inner ring with 20 centimeter height. Before wetting the inner ring, the surface of the inner ring is covered with the mulch. Why it is done? So when you irrigate this inner ring, you have to cover it with the mulch, because such that when you irrigate it, it should not splash and go out. So slow water infiltration should take place, should not disturb the soil surface. The next, record the initial height of water column in an inner ring, and the observation is continued for a specific period for 5 minutes, 10 minutes, 15 minutes, 30 minutes, 60, 90, 120 until the infiltration is complete. And refill the cylinder up to a convenient height if the water level is very low. So convert the reading in terms of centimeter per hour. So once the water starts decreasing infiltration into the soil, there is a scale over here. You can record at 30 minutes, 15 minutes, 60 minutes, 90 minutes how much water is infiltration, and you can express in centimeter per hour. This is the value taken. So the elapsed time for 1 minute, 3 minutes, 10 minutes, 25 minutes. The time in interval, the initial water level was 14 centimeter. Then after the field, after 1 minute, it was 12.5 centimeter. From 12.5 to it reached 12 minutes in 3 minutes, and in 10 minutes, it was stagnant. But up to 25 minutes, very little infiltration was there. This way, you can express it in a centimeter per rated infiltration rate. Infiltration rate in centimeter per hour is equal to difference in the level into the multiplied with 60 minutes divided by the time interval will give you the infiltration rate in the soil. So there is a classification. How much condition of the soil at what we call it as infiltration. If you see, the infiltration is very slow, medium and high. When infiltration is very slow, the infiltration rate is less than 0.25 centimeter per hour, or in inch it is less than 0.1 inch per hour. When it is slow, it is 0.25 to 1.25 centimeter per hour. or it is 0.1 to 0.5 inch per hour. When it is medium, then medium infiltration is important. So when it is medium, it is 1.25 to 2.5 centimeter per hour, or expressed as 0.5 to 1 inch per hour. And when it is high, very speed infiltration, it is more than 2.5 centimeter per hour, or it is more than 1 inch per hour. This is the infiltration rate of different soil depicted over here. You see the infiltration rate in centimeter. Infiltration rate is fast, further it starts decreasing intake. Then cumulative infiltration is total amount of water intake after a particular period of time. Yes, the infiltration rate with respect to the various soil type. In sandy soil, the infiltration rate is 30 mm per hour. In case of loamy soil, it is 20 to 30 mm per hour. In sandy soil, it is 12 to 20 mm per hour. In silt soil, it is 3 to 7 mm per hour. In clay soil, it is 3 to 7 mm per hour. And for clay soil, it is less than 3 mm per hour. This is the standard infiltration rate. This is for the today's class. In next class, we'll go with understanding of effective rainfall, what it is, what are the factors influencing effective rainfall, and how it is measured. Thank you.